Hi guys, this lesson is going to be on solving trig equations. And today we are going to find solutions in radians, and we are going to find them just between 0 and 2 pi. There are other problems that ask you to find all solutions, and you write kind of a formula for that. But today we're just going to be focusing on solutions between 0 and 2 pi. So I want you to think about how you solve a regular equation. You try to get the x, or the variable, by itself, and in trig equations you do the same thing, except you're trying to get the trig part by itself. So in this case, I have example 1, 2 cosine x equals -1, and I'll be focusing on trying to get the cosine x by itself. So I want to get rid of this 2. Since it's multiplied with cosine, I'm going to divide both sides by that. And that's going to give me cosine x equals -1/2. Now we are going to go to the unit circle to find what values, what angles are going to give us a cosine of -1/2. So I'm going to this free unit circle provided by embeddedmath.com. Definitely want to give them credit. Here I'm going to look for a cosine, which is the x value of -1/2. And you'll notice that it happens right here at 2 pi over 3. But if we scroll down, it will also happen here at 4 pi over 3. So I actually have two answers that is going to work for this problem. So I'm going to say x equals 2 pi over 3 and 4 pi over 3. So that is my solution set for this. Okay, and now we're going to go to another example, except I have 4 sine squared equals 1. So in this case, I'm going to divide both sides by 4, which is going to give me sine squared equals 1/4. And then you have to treat this as you would any other squared variable, and you want to get rid of a square by using the square root. So I square root both sides, and because they're inverses, we'll cancel over here on the left. And I have sine x equals, and again, if you think about when you take the square roots, you could have the positive or the negative answer. And you can look at the 1 and the 4 separately. So square root of 1 is 1, square root of 4 is 2, and I end up with positive and -1/2. So that's actually two different equations. I have one where the sine is equal to a +1/2 and one where the sine is equal to a -1/2. But I'm going to look both of those up on my unit circle. So let's start with the sine x equals +1/2. So sine is our y values on the unit circle. I find a +1/2 right here and over here. So I'm going to be using pi over 6 and 5 pi over 6 for this solution. So I'm going to come back and write x equals pi over 6 and 5 pi over 6. Now I want to look up where sine x is -1/2. So sine x is -1/2 here and here. So I'm looking at 7 pi over 6 and 11 pi over 6. So I have x equals 7 pi over 6 and 11 pi over 6. And that is our example 2. So example 3, we're going to have 5 equals secant squared x plus 3. And this time, to get the secant squared by itself, I'm going to subtract 3 from both sides. So 5 minus 3 is 2. I get 2 equal to secant squared. Again, it is squared, so I'm going to have to square root. So I square root both sides. And again, the square root and the square cancel, so I have secant x equals the positive and negative square root of 2. And then I think about what in the world can I do to solve that? Because I don't typically know my secants off the top of my head. I know my sines, my cosines, and, probably your tangents. But secant doesn't come to mind unless you are really involved in knowing your unit circle. So I'm going to use one of those trig identities that turns secant into 1 over cosine, because I know cosine pretty well. And so I'm just replacing that. And then if I think about how I can get rid of that so that it's on the top, or get the cosine to a top, because I can't just move it up there. It doesn't work that way. I have to multiply both sides by cosine to get rid of the fraction. It's going to cancel over here, and I'm going to have cosine x times positive and negative square root 2 equal to 1. And I'm trying to get that cosine x by itself, so I'm going to divide by positive and negative square root of 2. And over here on the left, that's going to cancel. So now let's come up here and look a little bit better at what we have. So we have cosine x on this side, and we have the positive and negative 1 over square root of 2 on this side. Now, although this is kind of ugly, you should kind of look at it as something sort of familiar. You can work on it to make it look like something on the unit circle just by rationalizing. So I'm going to come down here and do some scratch work. If I have 1 over the square root of 2, and I multiply it by the square root of 2 over the square root of 2, I get square root of 2 over square root of 4, which is square root of 2 over 2. So really, I'm looking at this 1 over square root of 2, but it is the square root of 2 over 2. So I'm going to change that. Now again, because I have the positive and the negative, I do have to look at two equations. I have cosine x is positive square root 2 over 2, and cosine x is negative square root 2 over 2. So I'm going to start with this first one, the positive square root 2 over 2, and I'm going to go to my unit circle. Cosine is the x value, so I have a positive square root 2 over 2 right here at pi over 4. And I also have one down here at 7 pi over 4. So I'm going to write these down, pi over 4 and 7 pi over 4. And now I'm going to go back and look for the negative square root 2 over 2. Okay, so cosine is a negative square root 2 over 2 at 3 pi over 4. And at 5 pi over 4, because that's where that x value is, the negative square root 2 over 2. So I come in, x is 3 pi over 4 and 5 pi over 4. And those are our answers for example 3. Okay, so example 4 is one for you to try. Take a minute, write this down, and then hit the pause button and work this problem out. So I'll give you a minute to hit the pause button. Okay, so now that you've had a minute to work it, again, your first goal would be to get that trig part by itself. So you would subtract 7 and get 4, and then divide by 3, so that became 4/3. To get rid of the square, you would square root both sides, which would cancel out over here on the right. The square root of 4 became a 2. The square root of 3 was just the square root of 3. And again, you get a positive and negative when you take the square root. This leaves you with an equation where you probably don't exactly know the cosecant answer. So I would turn the cosecant into 1 over sine. And then to get rid of that denominator, multiply both sides by sine. And then divide by the fraction 2 over the square root of 3. Now, at this point, I was running out of room, so I'm going to explain what I just did. So those canceled out, and I just had the sign on the left. When you have 1 over 2 square roots of 3, you want to flip the bottom and multiply, so you'd have 1 times square root 3 over 2, which gave me this right here. And then I went to my unit circle to look up where it was a positive square root 3 over 2. The sign is a positive square root 3 over 2 at pi over 3 and 2 pi over 3. And then I looked up the negative square root 3 over 2, which happens at 4 pi over 3 and 5 pi over 3. So if you'll check your work on this one, and then we'll move on. So for example 5, I have something that's a little different, and this should remind you of the look of a regular quadratic type equation. And if you remember with quadratics, we have options of factoring, solving by factoring, or solving with quadratic formula, things like that. And these today are just going to be factoring. So this is actually a trinomial type look, because we have cosine squared and then cosine and then just a plain number. So you can factor it into 2 parentheses. You guys know I use the X factor method. So I'm going to go through that and then I'll probably erase my scratch work so we can focus on what we're doing. But the point is to factor it. So I know that this is going to factor into 2 parentheses because it is trinomial look. So with my method, I would use the front number 2 and the back number 2 and multiply them and get a 4. The middle number is the -5. So what can I multiply to get a 4? That would add to give me a -5. And that would be a -1 and a -4, because a negative times a negative would be a positive, but then if I added those, I would get the -5. So I'm going to have cosine x instead of regular x like we would there, -1, and cosine x -4. So just like if I had 2x squared minus 5x plus 2, I would put x's in front. Because this is cosines, I put cosines here. The other thing you have to remember in this case is that I had that coefficient of 2, so I need to divide by 2 here and here. And it doesn't go in evenly here, so I'm going to swing it to the front. So I have 2 cosine x -1. But over here it does go in, so I have cosine x -2. So if you don't use this method to get here, that's fine, as long as you can get this into the 2 parentheses. So however you got to this point, we are factored, and it is similar to quadratics after that. You will set up 2 equations, so I have 2 cosine x -1 equals 0, and I have cosine x -2 equals 0. So here if I add 1, I have 2 cosine x equals 1. Then I want to divide by 2. And I have cosine x equals 1/2. So I'm going to go to my unit circle. I'm going to have to write my answer over here. Go to my unit circle and find where the cosine is 1/2.